Homogeneous linear equations. We will mainly study the second order homogeneous linear equations which have this form: a y double prime plus by prime plus cy is equal to 0, where a, b, c are constants, and y prime usually would be dy over dt, but it could be any derivative. It could be dy over dx as well. Okay, so the way we solve these equations is as follows. So we first write an auxiliary equation, which means we just repeat this equation, but instead of y double prime, we write r square. For y prime, we write r, and for y, we write nothing. So the auxiliary equation corresponding to this one will be ar square plus br plus c equals 0. And now this is just a quadratic equation. And what we do is we find the roots of this equation either through factoring or through quadratic formula. And then we could have three cases. The roots could be real and different. So in this case, the solution of the original differential equation is y is equal to c1 e power r1t plus c2 e power r2t, where r1 and r2 are the two roots, and c1 and c2 are constants. Second case could be, remember, a quadratic equation doesn't always have two different real solutions. Sometimes it could have repeated roots. So in this case, we say that the roots are real and equal. And let's say that they are both equal to r. r1 is equal to r2 is equal to r. So in this case, the solution is y is equal to c1 plus c2t e power rt, where r is the common root, repeated root. And then we could also have R1 and R2 be complex. So in this case, they will be complex conjugates, and R1 will have some form A plus IB, and R2 would be A minus IB. That's what's meant by being complex conjugates. And this big A and the big B are different from this little a and the little b. And in this case, the solution is y is equal to c1 e power at times cos bt plus I sine bt plus c2 e power at cos bt minus I sine bt. Now, this case will be studied in the next section. Right now, we're just mentioning it for completeness. But in this section, we won't have any problems relating to this case. Those will come in the next section. So let's look at the first example. Y double prime plus y prime minus 12y is equal to 0. And so the solution will be, remember, we first write the auxiliary equations. We write r square here, r here, and nothing here. So the auxiliary equation will be, let's just get it from here. So we will say the auxiliary equation is okay, so A is 1 in this case, B is also 1, and C is negative 12. Now, this one can be factored, but remember, mostly a general equation is not factorable, so you need to use quadratic formula then. So this factors into r plus 4 and r minus 3. R plus 4, r minus 3 is equal to 0. And r equals 4 or negative 3. So r equals 4 and negative 3. So solution will be, so remember this one, this is case 1, the roots are real and different. So in this case, the solution is C1 e power R1 is 4. It doesn't matter. You could have R1 as -3, so the order doesn't matter. And R2 is -3. And now this is the end as far as this particular problem is concerned. Sometimes initial conditions are given to us, and then we have information to evaluate C1 and C2. So in this case, this is the answer, C1 e to the 4t plus C2 e to the -3t. C1 e to the 40 plus C2 e to the -3t. I have the roots backwards, so let's go back. And let's see. Okay, R is equal to -4 from here, and C is positive 3. Positive 3. So this is -4, and this is positive 3. -4 and positive 3. Okay. So let's look at this one. Now the difference here, so it's 3z double prime plus z prime minus 3z. 3z double prime plus z prime minus 3z. Okay, we'll look at it in the next segment. So this is it.